billions of years ago. Before Earth, before the Sun, before life itself, there was only a vast cloud drifting through space. This cloud, a solar nebula, was made of gas, dust, and the remnants of ancient stars. Elements forged in stellar explosions long before our time. For millions of years, the nebula remained quiet. Then gravity changed everything. A shock wave, possibly from a nearby supernova, disturbed the cloud, causing it to collapse inward. As the material compressed, it began to spin. At the center, pressure and temperature rose beyond imagination. A star was born. Our sun ignited a blazing sphere of nuclear fire, anchoring the growing solar system. Around the newborn sun, leftover dust and gas flattened into a spinning disk. Within this disk, particles collided again and again. Slowly they fused. Grain by grain, rock by rock, planetary embryos formed. Closest to the sun, heat forced lighter gases away, leaving behind rocky worlds. Farther out, colder temperatures allowed gas giants to grow immense and powerful. This violent, chaotic process would continue for millions of years, giving rise to planets, moons, asteroids, and comets. Among these forming worlds, one would eventually become Earth. Earth did not arrive gently into the universe. It was born in violence. Around 4.6 billion years ago, countless fragments of rock and metal collided under the pull of gravity. Each impact released enormous energy, heating the growing planet from the inside out. At this stage, Earth was a molten world. Its surface was covered in vast oceans of lava, glowing red-orange against the darkness of space. There were no continents, no oceans, and no sky as we know it today. Relentless asteroid bombardment shaped the young planet. Every collision melted rock, fractured the surface, and added new material to Earth's mass. Heat came from three sources: the endless impact from space, the sinking of heavy metals toward Earth's core, and radioactive elements releasing energy deep within the planet. Together, they turned Earth into a blazing sphere of fire. Slowly, almost imperceptibly, change began. As the violence decreased and space debris thinned, Earth started to cool. The outermost layers hardened, forming the first fragile crust. But this crust did not last. Asteroids shattered it. Volcanoes tore it open. Lava resurfaced the planet again and again. Each cycle brought Earth one step closer to stability. This brutal phase would shape everything that came next: the atmosphere, the oceans, and eventually life itself. The young Earth was still incomplete. Then came an event that would define its future. Around 4.5 billion years ago, a massive protoplanet, often called Theia, crossed Earth's path. There was no avoiding the collision. The impact was catastrophic. When Theia struck Earth, the energy released rivaled billions of nuclear explosions. Entire layers of Earth's crust were torn away. Molten rock and vaporized metal were hurled into space. For a brief moment, Earth was surrounded by fire. The ejected material did not escape Earth's gravity. Instead, it formed a glowing disk of debris orbiting the planet. Within this swirling ring, chaos slowly gave way to order. Fragments collided, stuck together, and grew larger. Over thousands of years, a single body began to dominate. The moon emerged, scarred, barren, and still molten. This collision did more than create a satellite. It stabilized Earth's spin, controlled its tilt, regulated its tides. Without the moon, Earth's climate would have been wildly unstable. Life as we know it might never have arisen. From destruction came balance. After billions of years of fire, collisions, and chaos, Earth began to cool. Molten rivers solidified into the first fragile crusts, forming jagged landscapes across the planet. The atmosphere, thick with steam and volcanic gases, hung heavy and oppressive. Water vapor, released by volcanoes and trapped in the atmosphere, began to condense. Raindrops fell, first sizzling on the molten surface, then slowly filling the depressions of Earth's crust. Over countless years, these drops collected, forming the first oceans. The oceans were dark, deep, and alien, yet they were the cradle of life. They regulated Earth's temperature, absorbing the sun's energy and releasing it slowly. They shaped the land, carving valleys, shaping coasts, and filling lowlands. Meanwhile, volcanic outgassing released nitrogen, carbon dioxide, and other gases, slowly building an atmosphere. Oxygen was still absent, but the stage was set for life to emerge. From the glowing chaos of molten rock to the gentle rhythm of falling rain, Earth became a habitable world. The oceans marked the beginning of a new chapter, one that would eventually lead to the rise of life. For millions of years, Earth's oceans remained dark, hostile, and silent. But within this chaos, something extraordinary began to happen. Chemical reactions sparked in the primordial waters. Simple molecules collided, combined, and recombined. Over time, they formed the building blocks of life: amino acids, proteins, and nucleic acids. These molecules clustered together, forming protective membranes. Within these tiny bubbles, the first cells emerged, microscopic, fragile, yet capable of replication. Life at first was invisible, simple, and delicate. But it was persistent. It began to adapt, to respond to its environment, to harness energy. The oceans, once a molten wasteland, had become a living laboratory. Here in the depths, evolution had its first spark. Everything we know, every tree, every animal, every human, traces its origins to this moment. From chemical chaos to the first single-celled life, Earth had truly become a living planet.